All right, we've spent some time looking at equations and solving equations. We are now moving on to inequalities, and eventually we'll be solving inequalities. So let's just start off with talking about inequalities, and I bet you remember a lot about inequalities already. Of course, this is where it's not an equation, where the two sides are equal. This is where the two sides are unequal, and specifically one is greater than the other, or greater than or equal to. Okay, so let's look at all the different symbols that we might use in an inequality. We've got, of course, this one that you might remember is greater than. And we have kind of the opposite of that, which is this symbol, which is read as less than. There are two more, however, that you may or may not remember, and that is greater than or equal to symbol, where we have that greater than symbol, and underneath it, there's like half of an equal sign, the bottom line of an equal sign. And we do read that as greater than or equal to. And then we also have the correlating symbol of less than or equal to. And let's just kind of remind ourselves exactly what that means. An example of greater than symbol would be 8 is greater than 3, right? You might remember which direction the symbols go by thinking of the symbol as an alligator mouth, and it's always going to eat the bigger number. So 8 is greater than 3. And then, of course, you could say a less than statement like, no, you could say the opposite, 3 is less than 8. Right? So if 3 goes first, then of course the arrow or the carrot is going to go the other way, and the alligator is going to still be eating the bigger number, 8. But when we get to greater than or equal to, that means there's multiple options, right? So it would be true that let's see some different numbers. 5 is greater than or equal to -1. But it's also true that 5 is greater than or equal to 5, right? It can be greater than or it can be equal to. So 5 works here too, because the option of them being equal is a possibility. Then the same thing is true for less than. You could say that, so let's say -2 is less than -1, right? Less than or equal to -1, right? Because -2 is further down the line in the negative direction on the number line. So -2 is less than -1. But it's also would be true that -2 is less than or equal to -2, right? Because it has that option of being equal to. So both of these statements are true for the less than or equal to symbol, and both of these statements are true for the greater than or equal to statement. So what you might start to see or realize is that when we have inequalities, there's actually multiple solutions possible. So once we introduce a variable and we have a statement like x is greater than 19, now you can see there's all kinds of possibilities of what numbers would work for this statement. Of course, 20 is greater than 19, so x could equal 20. X could also equal 500 because 500 is greater than 19. So any number that's bigger than 19 would work for this situation. 19, of course, would not work. And, well, 10 would not work either, or any negative number. So, but anything greater than 19 would work. So here's what we do. Because we can't list all of the possibilities that would work for x, we can indicate the possibilities by drawing a number line. And I'm going to put 0 over here on the number line, and we're going to say that 19 is over here. And what we do is we say that the numbers that are possible are all the numbers that go in this direction. Let me use a brighter pen for this situation. Oh, there we go. You should be able to see that. All the numbers that go in this direction and all the way to infinity, positive infinity, would work. But would 19 work? No. Because 19 does not work, we're going to start by putting an open circle, right? X cannot equal 19. So we put that open circle to show that you can't be right on 19. You can be all the way up to close to 19 from this bigger direction, right? So it could be 19.1 or 19.01. Anything that's even just the slightest bit bigger than 19 will work, but 19 itself will not work. So we put that open circle. If we had the scenario X is less than or equal to, let's say 2, X is less than or equal to 2. Again, we could see that, well, 2 would be a possibility because it could be equal to 2, but 1 is also a possibility, 0 is a possibility, negative 0.5 is a possibility. There's all kinds of possibilities. So the way we show all the possibilities is, again, by drawing a number line, finding 0 on our number line. We'll mark out 1, 2 to find 2. And in this case, 2 can be equal to, X can be equal to 2. So we're going to put a closed dot. We're going to color in that dot this time. And after we color in that dot, then we're going to go less than. So we realize that 1 would work, 3 would be greater than 2, but 1 would be less than. So I know I'm going to go in this direction. And I'm just going to draw on top of my number line. It helps when you have a second color, but you can also use the same color, but just draw it really thick. So there we have 2 is a possibility for the value of X, so we put that closed dot. And then everything less than that is also a possibility, so we put that arrow going in the negative direction. So this represents X is less than or equal to 2. Now, these scenarios come up in real life actually quite a bit. For instance, you all are required to do 36 hours of community service every academic school year. And we're required to do at least 36 hours, right? So you could represent that as an inequality, that the number of hours, H, so let's just write this, at least 36 hours of community service. Now, H could be equal to 36, but you could also do more, right? If you did 40 hours, you would totally be meeting the requirement. So you could do 36 hours, but you could also do anything greater than 36 hours. So in this case, H is greater than or equal to 36. And of course, you could graph that on a number line. You could draw a number line. You could put 0 over here because we're going to go all the way to 36 here. And then we could see that we want to put a solid dot, color in that dot, because 36 is a possibility. And then you want to cover all the possibilities that are greater than 36, so you go in that positive direction as more numbers get bigger. Those are some examples of inequalities. You are going to be not only looking at inequalities like this and creating a graph, but also looking at a graph and figuring out what the inequality is. So let's look at one of those. What if I showed you a graph like this? So here's 0, and here is 1, 2, 3, 4, negative 4. And of course, it keeps going this way, and the numbers get bigger this way. But at that negative 4 point, I have an open, let me just make that line bigger. I have an open circle, and then the arrow goes in the negative direction all the way to the left. So now I'm wondering what equation might represent this, or what inequality, not an equation, what inequality is represented by this graph. Well, let's come up with a variable x, and then we know this kind of starting point is -4. We know it can't be equal to -4 because it's an open circle, not a closed dot. So we're not going to have that equal sign part of the symbol. But all of these numbers that are on this arrow that are possibilities for our variable are less than -4. So I know that I'm going to use that less than symbol. And you can test that out. You can say, okay, well, let's see. Here's -5. -5 less than -4. Yeah, that works. What about -7? -7 less than -4? Yeah, that works. So it looks like our arrow and our equation match up. So you should be able to go both ways, either seeing an equation and being able to graph it, or looking at a graph and then coming up with the equation.